Hello again. Once again, this is Ben Polzine, and I'm excited to dive into some TensorFlow projects. Today, we're specifically talking about this NLP project I've been working on. I do have a more extensive introductory video for this one, so if you're interested, take a look at that one. So for this one, I'll kind of glaze over the introduction other than to say we're working with the IMDB reviews dataset, doing some sentiment analysis prediction, and eventually we're going to even get into some optical character recognition, which will be fun. But for now, let's just get caught back up to where we were. We've built some a GRU and an LSTM model to compare the two of them and just kind of get a baseline, get a foundation to understand this problem space. And so we have both models performing similarly. Their curves look, equally kind of poorly. The diverging loss is not good, and the overfitting, there's already kind of clear signs for improvement. And thinking about that accuracy in terms of how an expert level human might perform, someone who's very familiar with movie reviews in the English language, they'd actually be expected to perform much better, more mid to high 90s in terms of accuracy. So we definitely can tell that there's definite room for improvement here. But that leads to the conversation of choosing the right architecture for the right situation. There's never a silver bullet for the best model for every situation. It's always going to depend on the situation. Sometimes you are going to need to optimize efficiency and simply satisfy a given accuracy threshold, and vice versa. And so in this case, the GRU is slightly more efficient, but slightly less accurate. But that's a common trade-off. But before we do too much tuning on these two models specifically, let's briefly talk about data-centric development versus model-centric development. So model-centric is very common, where you're hyperparameter optimization, tuning every piece of your model to really squeeze out every last drop of performance out of what you have. But what I prefer is data-centric development, which is looking at the problem space and thinking, how can we improve our data, either gathering more or cleaning up what we have, or otherwise, because if you have more and better quality data, you're going to have a better performing model. And so in terms of natural language processing, given how complex and nuanced the English language is and how many words there are, it's very valuable to apply a concept called transfer learning, which is to take a model that's been trained on millions of words using a large portion of the Wikipedia database as well as many different books to really get a true understanding of the English language, and then just simply apply that prior learnings to our specific data set and really fine tune our performance. And so we're going to do that with our good friend BERT, which is the bidirectional encoder representations from transformers. And we're going to work with the Ktrain Workflow, which is a very powerful wrapper, which is used to make interacting with these models very efficient. What would be many lines of code will end up being just a few simple lines of code. So we'll get our data set loaded up. We'll get our parameters and everything inputted so that we can load in our pre-trained model. And then we will once we have our model loaded, we'll train it on our data set, and we'll create a learner object, which we'll then be able to use to make our predictions with. So once we trained our model, it did take significantly longer, but it reached a much higher accuracy of 94%. And again, that's because of all that prior learnings that we were able to apply to our specific problems space. So that's awesome. We're able to just simply create our predictor and save it so that we can make predictions on generic reviews and see that we're performing very well. Now, there are fairly straightforward reviews, but it can even handle a little bit of sarcasm, like only watch this movie if you love horrible films. It can identify that that's a negative review. And so once we have our predictor saved, we can load it up in any other notebook or any application we want and use it later, which is awesome. And one thing that we can do is then apply that to an optical character recognition model. And so another really powerful tool that Google has created is called part2, which makes text extraction from images very straightforward, very simple. And so we're able to bring in an image like a movie poster with promotional quotes on it, extract the text off of it, and then make a prediction off of that text. So it's awesome. We've now got a function here that can take in multiple images, bring them in, print out the image, extract the text, and make the prediction. So really, honestly, a really impressive evolution from fundamental NLP to now optical character recognition with a functioning predictor all in about 5 hours. So I hope you enjoyed it and look forward to sharing more with you soon.